projects. In this video, we are going to explain about the project titled P2P Energy Trading System using Hyperledge Fabric. Introduction. This project introduces a decentralized peer-to-peer P2P energy trading system where sellers can list their available energy and buyers can bid on it. The decentralized nature of the system allows for direct transactions between sellers and buyers, cutting out intermediaries. Traditional P2P energy trading lacked privacy and robust verification mechanism. This left the system vulnerable to potential data exposure during server hacks or unauthorized alterations by individuals with internal access. The current project addresses these shortcomings by employing blockchain technology. Leveraging blockchain, specifically Hyperledge Fabric and Ethereum, this project establishes a decentralized server infrastructure. Blockchain provides inherent encryption and verification capabilities, ensuring secure shortage of transaction records and blocks. This prevents unauthorized data tampering, enhancing data integrity, privacy, transparency, and fault tolerance within the P2P energy trading system. Objective. The primary aim of the project is to establish a secure and transparent peer-to-peer P2P energy trading platform. This is achieved by integrating blockchain technology to enhance privacy, build trust among participants, and optimize the efficiency of energy transactions. Blockchain is utilized as the core technology for decentralized data management within the P2P energy trading system. It ensures that energy transaction records, bids, and recommendations are securely stored, making them immutable and verifiable. This decentralized approach enhances trust and security. The secure hash algorithm SHA is applied to generate unique hash codes for each data block, particularly for transaction records. These hash codes serve as a fingerprint for the data, enabling verification and detection of any alterations or unauthorized changes. By utilizing SHA, the project ensures the integrity and security of the stored data in the system. Requirements. The requirements of the project are hardware requirements, in which we have processor of 5 and above, RAM of 8 GB and above, ROM of 25 GB and above. Software requirements, in which we have Node.js, Python 3.7.0 version, and Visual Studio Community version. Methodology. To implement this project, we have designed the following modules. The first module is Seller. Sellers list their available energy, review buyers' bid, and accept bids to facilitate energy transactions in the P2P energy trading system. Buyer. Buyers place bids on listed energy, receive energy predictions and recommendations for battery usage, and monitor bid status for effective energy procurement. EV user. EV users provide battery recommendations, assisting buyers in selecting suitable batteries based on make, model, and battery life, promoting efficient electric vehicle energy usage. Blockchain integration. The project successfully realized a decentralized peer-to-peer P2P energy trading platform, a significant departure from traditional centralized methods. This decentralization directly addressed concerns regarding privacy, security, and transparency that were prevalent in conventional energy trading systems. Through this approach, the users can engage in secure and transparent energy transactions while maintaining privacy. Through the integration of Hyperledge Fabric and Ethereum blockchain, the project showcased how blockchain technology can significantly bolster data security, integrity, and trust within the context of energy transactions. The immutability and decentralized nature of blockchain ensure that energy transaction data is securely stored and tamper-proof, providing a high level of trust and data integrity for all participants involved. The project emphasized a user-centric approach by designing a user-friendly web interface. This interface enabled smooth interactions for users, including easy sign-up, energy listing, bidding, and recommendations. By prioritizing a seamless user experience, the project ensured that sellers, buyers, and EV users could efficiently navigate and engage with the P2P energy trading platform, promoting active participation and usability. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the P2P Energy folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is P2P Energy app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. This P2P Energy app folder also contains a templates folder. Within this template folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. This folder also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is helloeth folder. Inside this folder, I have node modules folder. This folder consists of dependencies or modules needed for the project. Open the .bin folder. .bin folder often contains executable scripts related to the project's dependencies. So here we have run blockchain.bat file. Double click on it to start the blockchain. This script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at this local host, which is this, and port, which is this. This address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. This is the contract address. This address represents the location of the deployed smart contract on the blockchain. This is the gas used to execute the Solidity file and compile smart contracts. This is the amount of gas consumed. Now minimize this. Go to the main directory. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is P2P Energy Solidity file. This file consists of Solidity code. It handles data structures, functions, and events with modifiers for validation. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the Django application. The Django framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome, and type index.html at the end and hit enter. This is the homepage of the project displayed in the browser. This is the front end built using Django framework. Now click on user sign up to register. So here we need to enter all these details. So I'm entering the details. Password, contact number, email ID, address. Here the user type is seller. Now click on register. So here we can see sign up process completed and record saved in blockchain. Now again click on user sign up to register one more user, that is the buyer. So I'm entering the details of the buyer. So here the user type is buyer. Now click on register. So here we can see sign up process completed and record saved in blockchain. Now click on user sign up link to register one more user, that is EV user. So I'm entering the details of the EV user. So the username here is TrueProjects3. Now enter the password and the contact address and the email ID and the address. So here the user type is EV user. Now click on register. So we can see that sign up process completed and record saved in blockchain. So we have registered 3 users, that is a seller, a buyer and a EV user with different username and password. Now click on EV login link to log in as EV user and add recommendation battery details. So here we need to enter the username of the EV user and the password, and here the user type is EV user. Now click on login. So we have logged in as TrueProjects3, that is the EV user. Now click on add battery life details to add the details. So here we need to add these details. Battery make is Emeron, model HCT, battery capacity 30 days and rent per day is 200. After entering all these details, click on submit. So here we can see battery lifetime details added in the blockchain. Now click on logout. Now click on seller login to add energy details. So here we need to enter the username and the password of the seller. So I'm entering the username and the password and the user type here is seller. Now click on login. So we have logged in as TrueProjects1, which is the seller. Now click on add available energy link to enter the available energy. So here we need to enter the current available energy, which is 10,000 kilowatts and price per unit is 10. Now click on submit. So here we can see energy details added in blockchain. Now log out. Now click on buyer login to log in as the buyer. Enter the username and the password of the buyer. So I'm entering the username and the password, and the user type here is buyer, and click on login. So we have logged in as TrueProjects2, that is the buyer. Now click on choose seller and place bid link to view available sellers and then bid for desired seller. So here we can see we got the seller ID, which is 2, we got the seller name, that is TrueProjects1, and here we can see the available energy, which is 10,000 kilowatts and price per unit is 10. And here we can see the option to buy. So if we click here on this click here link, we can sell for the bid. So here we need to enter the bidding price which we want. So I'm entering the price as 9. So here we can see that the buyer is bidding at price 9, which means he wants to take for 9 per unit against 10 given by seller, and this request will go to the seller. Seller may accept or ignore that bid. So now click on submit. Now click on load prediction link. So here we can see the recommended consumption for the different sources. Now click on view bid status to view the status. So here we can see the request ID, the buyer name, the contact number, seller ID per unit, and the seller name, which is TrueProjects1, and the bid price which is given by the buyer is 9. And here we can see that the status is pending. So the seller needs to approve the status. Now click on view recommendation to view recommendation on batteries. So here we can see battery supplier name is True Projects 3 and the contact number and the make, model, capacity, rent of the battery. Now log out. Now log in as seller. Enter the username and password of the seller. User type here is seller. Now click on login. Now click on view and accept buyer bids to accept. So here we can see the status is pending. So if we click here on this click here link, the seller can accept the bid. So we can see that the bid price is 9 and the seller price was 10. So the seller wants to accept this price. So the seller will click on click here link. So we can see that the bid is accepted. Now again click on view and accept buyer bids to view the status. So here we can see that the status is accepted. Accept bid request is already accepted. Now log out. So in this way the seller and buyer can negotiate using the application. Conclusion: the project successfully demonstrated the implementation of a decentralized peer-to-peer P2P energy trading system where energy transactions occur directly between sellers and buyers. This departure from traditional centralized methods addresses key issues of privacy, security, and transparency that were prevalent in the legacy energy trading systems. The decentralization enhances privacy by removing intermediaries and allow for a transparent and efficient energy trading process. Integrating Hyperledge Fabric in Ethereum blockchain showcased how blockchain technology enhances data security, integrity, and trust within the P2P energy trading system. Blockchain ensures secure and immutable storage of energy transaction records, bids, and recommendations. This immutable ledger enhances trust among participants by providing a tamper-proof and transparent history of transactions, fostering a high level of data integrity and security. The project prioritized user experience by incorporating a user-friendly web interface. This interface simplifies the interaction for sellers, buyers, and EV users, allowing easy sign-up, energy listing, bidding, and access to recommendations. The emphasis on usability ensures that participants can seamlessly engage with the platform, promoting active involvement and a positive user experience throughout the energy trading process.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.